Hello, welcome to the magic of triangles. Now the thing with the triangle is that it's not at all like the rectangle. Why? Because it's got three sides. Actually, that's a bit of a myth. It's actually very much like a rectangle. In fact, it's actually half of a rectangle. And I'm just going to show you something that's a bit of an idea. If I was to draw a line at right angles down there, and then this triangle here, I was to double it. And the same with this triangle here, I was to double that. The outside box is actually a rectangle. In other words, two lots of that and two lots of that make a rectangle. And we know that when we find the area of a rectangle, it's just base times height. We also know if this triangle underneath that's hidden in the rectangle is exactly half of the rectangle, then it's going to be base times height divided by 2. And so what we know is the area of a triangle is base times height divided by 2. And some people also write this as half base times height. It's the same thing. And so how would we work this out? Well, two things we have to look for is the distance of the base, so from here to here. A lot of people try to find from here to there and then from there to there. No. The base is the entire distance across, which is 2.8 centimetres. And then we find the height, which is always at right angles to the base. So we look for the right angle. Oh, boom! There it is! And we times that 17.4 by 2.8. We have a problem that we haven't recognised. Sorry, it's base times height divided by 2. What's this problem we haven't recognised? I'll give you a hint. This clearly looks bigger than that. How can 2.8 centimetres be more than 17.4? Because it's in millimetres. That's in centimetres and that's in millimetres. That means that we need to do our conversions. Remember our conversions? 17.4 millimetres is just 1.74 centimetres. And we can't do these area equations unless the units, pardon me, I'll make that 1.74 centimetres, unless they're the same. So now, let's punch it straight into our calculator. 2.8, can't really see it, let me just bring that back down, times 1.74 equals, divide by 2, oops, let's try that again. 2.8 times 1.74 divided by 2 equals 2.436 centimetres squared. All right. So let's just summarise what we did there. All we did was multiply the base by the height and then divide that answer by 2. Now, if you like half base times height, you could have just done it like this. Half times 2.8 times 1.74. That's still in frame. And you still would have got 2.436 centimetres squared. So it's base times height divided by 2. But now we get something that looks a smidge different. A little bit different. Have a look at this bad boy. This triangle doesn't look like the other triangle. And so the first thing we need to think about is which one's the base and which one's the height. It doesn't actually matter. All we need to look for is the right angle. Found it. And the two lengths that are separated by the right angle, in other words, 7 and 6, can be the base and the height. And you can swap them around, it doesn't really matter, because area equals base times height divided by 2 with triangles. And in this case, it's just 6 times 7 divided by 2, which equals 42 divided by 2, which equals 21 centimeters squared. Now, if I was to make that 7 times 6 divided by 2, it would still equal 42. It doesn't actually matter. So when we get these triangles, which we call skewed triangles, skewed because they're on a lean, these skewed triangles, it doesn't really matter. We just look for the right angle and we multiply the two things, or the two distances that are separated by that right angle, and then divide it by 2. Thanks for watching the magic of triangles. See you next time.